All right, welcome back. Let's do these two practice problems together. So we have a root 12 in the denominator. So we're going to multiply top and bottom by root 12. Root 12 times root 12 becomes 12, so that just goes away. Root 17 times root 12, we need to do as the square root of 17 times 12. And 17 times 12 is 204. So this is root 204 over 12. We really should check that root 204, if that can be simplified further. I know that we can divide that by 4. Let's check to see if there's any higher square numbers that can go into this. So again, I'm writing my square numbers along the top here. And then we'll see if any of these other ones go into it. So 100, no, doesn't work. 121, we'll go one more further. That one doesn't work. 81, no, that doesn't work. Let's see, let's see here, 64. 204 divided by 64, nope, that doesn't work. 49, I don't think that's going to work. 36, I don't think that's going to work, but you know, I'm just checking these things. 25, definitely not going to work. 204 divided by 16, nope, that doesn't work. Divided by 9, nope, that doesn't work. So it's 4, yeah. 204 divided by 4 is the best we're going to get. This becomes root 4 times root 51, which is 2 root 51 over 12. And look, we actually have one last step here. This is 2 over 12. That can actually be reduced to 1/6. So there's our final reduced answer, because we could reduce the radical, and then we could reduce that fraction 2 over 12. Let's do this one over here. We are multiplying, again, we multiply by the same thing, except when there's two terms, we're going to switch the sign. So this is 8 plus root 3. So the bottom becomes 64, and that's negative 8 root 3 and positive 8 root 3, so those cancel, and this is negative 3. So that's a 61 in the denominator. And then the top, the 4 distributes to become 32 plus 4 root 3. None of those things are going to cancel, so there's my final answer. 32 plus 4 root 3 over 61. All right, like I said, I know that these ones need a little bit of practice, right? So we've got a couple more problems on your assignment tonight to practice with. But let's go ahead and do the last set of examples here where we're solving a quadratic equation. So solving a quadratic, we're going to use the same steps as other solving, right? The goal is to get the variable isolated. To do this, we use opposite operations in order to undo operations from each side. And whatever we do to one side, we do to the other side. This is the same as all solving that we have done thus far. The only thing that's different now is we have this additional operation of the square. So what we're going to do is isolate this portion, the square portion. So we do that the same way as before. I'm going to subtract 5 from both sides, get 3x squared equals 36. I'm going to divide by 3, and I'm going to get x squared equals 12. Now, I'm not done because this is x squared, and I need it to be x. So what operation is the opposite of squaring? And that is the square root. So I square root both sides, and I get x equals. Now, the funny thing here is when we do this square root, we need to make sure that we add 2 answers, because it could be positive or it could be negative. So this is plus or minus the square root of 12. And I better make sure that I can reduce this or not. 1, 4, 9, 16. Do any of these square numbers divide evenly into 12? Yep, 4 does. So this is root 4 times root 3, or 2 root 3. So there's my solution for that one. Again, solve like normal, but then do the square root to cancel the square. Make sure you add the plus or minus. Here we have 1/5 times z plus 3 squared. Notice that the squared is in this whole thing. I'm going to get rid of this fraction first by multiplying by 5. This is dividing by 5, so I'm multiplying by 5. This becomes z plus 3 squared times 5 makes this 35. Now, because the squared portion is isolated, I'm going to square root both sides because I get z plus 3 equals plus or minus root 35. Notice that I canceled out the square by square rooting it. Now, I need to do this one last step to get the z by itself, which is to subtract 3. And so I get z equals, and I'm going to put the negative 3 here in front of the plus or minus and do that. And I should check, does the root 35 reduce 1, 4, 9, 16, 25? Do any of these numbers divide evenly? 25, no. 16, no. 9, no. 4, no. Okay, we're good. So this right here is our final answer. Notice the difference between these two problems. This one, I got it all the way down to x squared before I did the square root. This one, the parentheses had the square, so I had to get the parentheses by itself, then do the square root, and then do an additional step after that. All right, there's a couple more practice problems for you on your notes. Please go do those and then come back for the solutions in the next video.